Graphs and figures. Hello, everyone. I hope that you are ready to learn about graphs and figures. I will post the PDF so you can take a look at it after you watch the video. Okay, here is a graph. So you can just read that percentage of unnecessary graphs. So in the blue is necessary graphs. I hope this presentation is a necessary presentation. Why do we need graphs and charts? That is the question. So you can pause the video and think. Try to think of an answer. Well, I could not hear your answers, but I hope your answer was because everybody hates numbers. Okay? Because that's true. Everybody hates numbers. Look at this table full of numbers. Nobody wants to see that. Look at this table. So many numbers. Nobody wants to see that. Except for maybe this guy. He loves numbers and data. But for a normal person, that's too much. So, what can a graph do? A graph is a visual representation of numbers or data. It's an easy way to present a large amount of information. Trends are easy to identify, and it can be more organized than that boring data table. Trends. Trends basically tell us where the data is going. Here, for example, we can look at some gun data, and we can look at the trend, and we can see that the more guns a country has, the more likely it is to experience gun deaths. All right? Or maybe you've heard of global warming. It's kind of a hot topic. Here we can see a trend that we call the warming trend. Okay? So we see that the temperature is increasing. If we want to talk about trends, we see that we have different words we can use. So these are important for you guys to look at and to use when you speak about trends. Okay, hint, hint. So we have decreases. They can be gradual, they can be rapid. We have increases. They can be gradual, they can be rapid. We have rapid changes or fluctuations. And the data can be flat or steady or stable. You can find more words online. Let's look at some different types of charts. First, we have a bar chart or bar graph, some people call it. In this example, I think 100 people were surveyed about their favorite fruit, and I guess this is from the United States because the most popular fruit is the blueberry, a very American fruit. I like blueberries. I hope you like blueberries. I don't know if it's my favorite. If you want to show proportion, okay, so part of a whole, you can use a pie chart. Someone said in France you say camembert, I think. So in America we prefer pie. Here you can see the word origins of the English language. So 29% of our words come from French and 29 from Latin. English is almost a Romance language. Now we have a line graph showing the average number of tornadoes per month in the United States in 2009 to 2011. So it only takes 1 second to see which area has the most tornadoes, which month has the most tornadoes. All right, so if you love tornadoes, go to America in April. Personally, I don't like tornadoes. Here we have the classic sleeper chart. This is the chart that puts everyone in the room to sleep. You should always avoid this chart. Sometimes companies, to avoid the sleeper chart, they get creative. So here are a few examples. If you like cats, for example, I don't. If you like to be sick, or if you like companies that make a lot of money. Unfortunately, sometimes it is difficult for people to make good charts. So let's see what happens when frustrated people make bad charts. So here we have same numbers, different story. So if we want to look at interest rates, for example, if I want you to believe that the interest rates are so high in 2012, I can do magic with my chart. Let's look at another chart with the same data. Oh, but this chart starts at 0, where a chart should start. And it looks like the interest rates are actually flat, not rising. Tricky. Maybe you've heard of this company. They often have bad graphs. So I don't need to do the math in my head, but I'm pretty sure that 6 million is not less than half of 7 million. Okay, so a problem with proportion. Okay, so here we have our pie chart, and the circle represents 100%. But if we add these percentages, I think there is a problem. Okay, so another pie chart about Americans who have tried marijuana. And it looks like the person who made the pie chart might have been using marijuana. And then there's this. This is not very useful. Okay, so if you choose the wrong chart, you have said nothing with your data. Alright, so now we're going to see a video that explains bad use of charts and figures and data much better than I can.
A toothpaste brand claims their product will destroy more plaque than any product ever made. A politician tells you their plan will create the most jobs. We're so used to hearing these kinds of exaggerations in advertising and politics that we might not even bat an eye. But what about when the claim is accompanied by a graph? After all, a graph isn't an opinion. It represents cold, hard numbers, and who can argue with those? Yet, as it turns out, there are plenty of ways graphs can mislead and outright manipulate. Here are some things to look out for. In this 1992 ad, Chevy claimed to make the most reliable trucks in America using this graph. Not only does it show that 98% of all Chevy trucks sold in the last 10 years are still on the road, but it looks like they're twice as dependable as Toyota trucks. That is, until you take a closer look at the numbers on the left and see that the figure for Toyota is about 96.5%. the scale only goes between 95 and 100%. If it went from 0 to 100, it would look like this. This is one of the most common ways graphs misrepresent data, by distorting the scale. Zooming in on a small portion of the y-axis exaggerates a barely detectable difference between the things being compared. And it's especially misleading with bar graphs, since we assume the difference in the size of the bars is proportional to the values. But the scale can also be distorted along the x-axis, usually in line graphs showing something changing over time. This chart showing the rise in American unemployment from 2008 to 2010 manipulates the x-axis in two ways. First of all, the scale is inconsistent, compressing the 15th-month span after March 2009 to look shorter than the preceding 6 months. Using more consistent data points gives a different picture, with job losses tapering off by the end of 2009. And if you wonder why they were increasing in the first place, the timeline starts immediately after the U.S.'s biggest financial collapse since the Great Depression. These techniques are known as cherry picking. A time range can be carefully chosen to exclude the impact of a major event right outside it. And picking specific data points can hide important changes in between. Even when there's nothing wrong with the graph itself, leaving out relevant data can give a misleading impression. This chart of how many people watch the Super Bowl each year makes it look like the event's popularity is exploding. But it's not accounting for population growth. The ratings have actually held steady because while the number of football fans has increased, their share of overall viewership has not. Finally, a graph can't tell you much if you don't know the full significance of what's being presented. Both of the following graphs use the same ocean temperature data from the National Centers for Environmental Information. So why do they seem to give opposite impressions? The first graph plots the average annual ocean temperature from 1880 to 2016, making the change look insignificant. But in fact, a rise of even half a degree Celsius can cause massive ecological disruption. This is why the second graph, which shows the average temperature variation each year, is far more significant. When they're used well, graphs can help us intuitively grasp complex data. But as visual software has enabled more usage of graphs throughout all media, it's also made them easier to use in a careless or dishonest way. So the next time you see a graph, don't be swayed by the lines and curves. Look at the labels, the numbers, the scale, and the context, and ask what story the picture is trying to tell.
Okay, that was a great video. Now, let's see, sometimes graphs and charts can be fun. So let's see some fun graphs. Here is a graph about the reasons to love France. So I guess it was a survey and they asked people, and it looks like 50% of the people said the wine, 50% said the food, and okay, let's look at the next one, sorry. A pie chart. This is a pie chart. All right. Okay, so this very interesting graph of a pyramid in the sky. All right, if you see it, wow. So for you math students, this is how your life will go. You have the elementary math, you have the middle school math, you have college math, and then when you get a real job, you see what you will do. Only spreadsheets. Okay, so I said that graphs and charts were better than data, better than numbers, better than data tables. But there is something better. Infographics. Infographics are better sometimes. They are eye-catching, they are easier to process, and they are easily shared. So we don't really care about web traffic. You can even make an infographic about infographics. So here you can see just some common techniques used in infographics. All right. Thank you for watching until the end. You will find the infographics about infographics on the PDF. You will be able to zoom in and read what they say and learn about the wonderful world of infographics. And I will talk to you next time.